Let's suppose that we have the inequality x greater than or equal to 1. We could graph this on the number line pretty easily just by putting a closed dot at 1, filled in dot because this says equals, and then shading to the right. So indicating that x could be anything from 1 on to infinity. And using interval notation then, interval notation we use by reading left to right, where does an interval start and where does it end? This one starts at 1 and then goes on to infinity. And we use a bracket to indicate inclusion and a parenthesis to indicate exclusion. So in other words, we're going to put a bracket here at 1 because it's a filled in dot and because it says equals here. So the number 1 is included in the set. We always use a parenthesis at infinity because you can't include infinity. You can't point to it, you can't touch it, you can't graph a dot at infinity. In other words, it's an open, this is called an open interval endpoint because it never actually reaches a value, where this is a closed interval endpoint, the bracket, because it does terminate at this value 1. So if we look at another example, let's say we've got minus 2 less than x less than or equal to 4. Okay, so again, graphing this, we'd start by putting an open hole this time at minus 2 because it doesn't say equals, it just says less than. And then we'd go up to 4 and we'd put a filled in dot there because it does say equals 4 here. And then x can be anything in between these values, and so we're going to shade in between minus 2 and 4, not including minus 2 and including 4. So this interval, reading from left to right, would be minus 2 to 4 with an open parenthesis and then a closed bracket. We're not including minus 2, so the inequality sign, the strict inequality without an equals part, the open hole, and the parenthesis all go together. The inequality with the equals part, the closed dot, and the closed bracket all go together. Now let's look at a case where we have what's called a disjoint couple of sets. Let's suppose that we have here minus 1 with a filled in dot, and then it extends out to the left to infinity like this. And then we have an interval here that goes from, let's say, 2 with a closed dot up to infinity. And we wanted to express this in interval notation. We'd start at minus infinity, and we'd go to minus 1. So reading left to right with this part here, we'd start at minus infinity and put a parenthesis, because you always put parentheses at infinity, and then we would have a closed bracket at minus 1. But that's not all there is on this graph. We would have to say union or, same thing. So in other words, x could be in this interval or in this other interval here, where we're going to have a closed bracket, 2, comma, infinity, parenthesis. 2 to infinity, reading left to right, starts at 2, goes to infinity, closed bracket at 2 because we have a filled in dot, open parenthesis at infinity because we always put parentheses at infinity. So if we had something like 4 to 10 with brackets, so there's an interval, and if we wanted to graph that, we'd have filled in dots at 4 and 10 and shaded in between. If we wanted to express this As an inequality, it would say 4 less than or equal to x less than or equal to 10. Again, everything goes left to right. On the number line, when we look at it, it goes from left to right, 4 to 10. Our inequality from 4 to 10. And our interval from 4 to 10, reading left to right.